Hey guys, so today we're going to solve one of the problems from Geeks for Geeks, which is to find the longest palindrome in a string. And so the basic idea of this problem is that, so for example, if we have a string here, right? So we have A, B, and then A. So what exactly does it mean by palindrome, right? So uh, palindrome means that even if we reverse the string, it still has the same spelling and it still sounds the same. I mean, you can't pronounce A, B, A, right? So, but like even if you reverse the string, it still has the same structure in it. So that's the problem statement. I'm supposed to find the longest palindrome in a string. So for example, here the given string is not a palindrome like the one we just saw now. But if we take this, if we look at the string and if we found that AA and then BB and then AA, we find that this is a possible string, right? That can be a palindrome. And even if we take AA, that is still again a palindrome. And even if we take AAAA, that is still again a palindrome. And if we take BAA, that's still a palindrome. Because even if we reverse BB, we still get a palindrome. So that's the idea behind this. But even if there's a lot of palindromes in the provided string, we're supposed to find the longest palindrome in the provided string. So that's the problem that we're given. And so we're going to use dynamic programming to solve this problem. And the way that we do that, let me erase this. Just going to erase this and create A, B, A, A. Right? So this is going to be our rows and this will be our columns. And we are going to create a two-dimensional array. So this is supposed to be A, supposed to be B, A, A. So we will initially set a two-dimensional array. So just give me a second. My drawing's not that good. Anyway, so this kind of looks like an array, but yeah. So the first thing that we do once after we build out an array is that we'll first start to we will first start to look at the diagonals, right? So for example, here we let me also have the full array here as well, so that we have a point of reference A, B, A, and then A. The first thing that we do is we take a look at the diagonals, and we'll start from 0, 1, 2, 3, and 4, and then oops, zoom out 0, 1, and then 2, 3, and 4. So we will initially look at all these diagonal elements, right? So 0 and 0, A and A. So we're looking at A here. So A and A, again, any single character is again a palindrome of itself, because even if we reverse A, we still get A. So in this case, we can just put in 1, because this is the length of the palindrome. Length of A is again A. So we can do the same again for every diagonal elements, because again, like A and then A is 1. If you take the elements from 2 to 2, which is 0, 1, oops, and 2, 3, 4. So 2 to 2 here is B. So even if we take just the B element, we'll still get a palindrome of 1. And then we're going to do the same for, again, A and A is going to be 1. A and A is going to be 1. Next, we're not gonna consider all these stuff. We don't need them. And the only elements that we need is the one that are above this. So next, we are gonna consider 0 and A. So this A and this A. So elements from 0 to 1. So 0 and 1, right? So in this case, we have two elements. So we don't need to check any other part other than these two elements. So when we have just like two elements to compare, right? So 0 and 1, it's just the difference between them is 1. So 0 minus 1 is 1. So in this case, we don't have to compare anything else. We can just compare A and A. So again, A and A is a palindrome. We just need to check if the elements are equal. And if they're equal, we can put in 1. Oh, sorry. If they're equal, we need to put in 2, because the length of the length of the string here is 2, so we need to put in 2. Again, we'll do the same thing for this row. So A and B, again 1 and 2 here. we will compare 1 and 2, and in this case it's different, so we'll not be filling in 2, we'll be filling in 0 because that's not a palindrome. And then we will again check B and A here, 2 and 3. 2 and 3 is not same, so we'll put in 0. And then we will check A and A here, 3 and 4. Those two are same, so we will put in 2. So far this file is straightforward, guys, because we just checked the same element in this iteration, and in the second iteration we just checked two elements. We didn't go into any dynamic programming, we just compared the characters, and if they're equal we just populated 2 or 0. So the next step is the important one, because what we need to do is, in this case we are checking 0 to 2. This became 2. I'm gonna erase this, so complicated here, so I'm gonna write a new thing. So A, B, A, and then A, right? So 0, 1, 2, 3, and then 4. So here we have 0 and 2. So we need to compare from 0 and 2 again. So in this case, the first comparison that we can check is whether if the last elements, that is the one that we're comparing, 0 and 2, we can check if they are equal or not. So in this case, they're not equal. If they're not equal, there's no possibility of it being a palindrome at all. So we can go ahead and put in 0 here. And then we can compare 0 and 3. Not 0 and 3, we need to go diagonally. So 1 and 3. So 1, 2, 3 here, right? So this is pretty interesting because the element at 1 index and the element at 3rd index are equal. So we found out that they are equal, right? So if they were not equal, we would have filled in 0. But since they're equal, what we need to do is we need to check if the element that's between them, which is B here, is a palindrome. So the way that we do this is by checking the element at position I. So this should be our J, and this will be our I. So we need to check if the element at position I plus 1 and j minus 1 is non-zero, right? So if we are here and we need to check I plus 1 and j minus 1. So I plus 1 and j minus 1 is the element here. So what we need to do is that we need to check if the element here is 0 or not. So if it is not 0, we need to add this plus 2, because we found elements, two elements here, A and A, and we've already found that the length of the palindrome so far is 1. So we need to take this 1 and then we need to add it to 2. So 1 plus 2 here, it would be 3. So 1 again plus 2, the elements that we found so far would be 3. So that's what we're putting in here, and then we'll go to the next one. So in this case, which is 2 and 4, again, like 2 is B and 4 is A, completely different elements, so we don't need to do a comparison of the element at this position, so we can directly put in 0 here. Next, we are going to go for the next diagonal, which is from 0 and 3. So 0 to 3 is all the way here. Wait, no, it's all the way here. So confusing. I'm going to erase all this. Yeah, I'm going to check 0, 1, 2, 3. 3 is all the way there. But so the basic idea is 0 to 3 is here. And the first thing that we do is we check if the last elements are equal. So in this case, A and A, they are equal. And the next step that we do is we check if the element at I plus 1 and j minus 1 has a value that is other than 0. So the way that we do is we check here. So I plus 1 is here and j minus 1 is here. So we check here, right? So when we check here, the value is 0. So these are, which indicates that these elements that's here are not a palindrome. So there's no point in adding value here. So we will directly put in 0. So we go on to the next diagonal, which is here. Again, we check from 1 to 4, which is all the way from here to here. We will check the end values, which is A and A. A and A are equal. So A and A are equal, so we check the element that's here right now, 0. So it's not a palindrome, So meaning that elements that are between those two pairs are not a palindrome, so we directly go ahead and add in 0. So we move on to the last diagonal here, which is 0 to 4, right? So this is pretty interesting. I'm gonna delete all this. Super important to look at here now. So 0 to 4, so which is all the elements basically. So the first thing that we do, as we have done so far, is check if 0 and 4 are same. Again, in this case, they are same. And then what we do is we check if all the elements that are between 0 and 4 is a palindrome. So the way that we do that is we check the element at this position. So we have a non-zero element here and there is value to this. So what we do is we get 3 here, right? And then we add these two elements. So which is again 3 plus 2 characters, and then we get a 5, which is what we're supposed to put in here. So the maximum that we found throughout all this iteration is 5. And we were able to find that the maximum string in this case starts from 0 and ends in 4. So this is how we find the maximum palindrome in an array. And now I'm going to code this out in Java here. So I've already did a bit of coding, that's why you see some stuff already printed out, but we're going to start coding. It's going to be interesting. So we're declaring a few variables here, max start and max end, and the length of the string that we get and the maximum so far, just so we can keep track of some stuff. The first thing that we do is we declare a two-dimensional array, right? So I'm going to declare it as dynamic programming, and then I'm going to set it to the length here. And then the next step that we need to do is we need to declare another character array. Set it to, we're going to use a really cool Java method, oops, to change it to an array, where so that we get a list of an array of characters from the string that's provided to us. So the next step is to iterate from I is equal to 0 to I is less than length. You know what? I'm gonna name this something different because we're gonna set another index I internally there. So index is less than length and then I plus plus. So remember guys, so we are iterating through the string, right? So the first thing that we need to keep in mind is that we are planning to iterate on a diagonal fashion rather than on a row by row fashion, right? So here, so if you take a closer look into this, right? So the first iteration that we do is we'll start from I is equal to 0. This is the for loop that we just written now. And inside I is equal to 0's for loop, we'll have another. So you know what? How do you? Yeah. So the first index. So during the first I is equal to 0's iteration, the first time that we go through is we will have 0 and 0. And then the next iteration inside I is equal to 0, we will have 1 and 1. And then we will have 1 and 2. So this is for the index index is equal to 0th iteration. And if we had index is equal to 1, which is the next iteration, we will start from 0 and 1. And then we would go to 1 and 2. And then we would go to 2 and 3, right? So 2 and 3. And if we had index is equal to 2 here, we would start all the way from 0 and 2. So guys, you see a pattern here. So what's happening is that we are setting I during I every iteration we are starting from 0. We are starting from 0 and here we are starting from 0. But J on the other hand, we are starting from the index value. So in this case, we are getting the index from there and we're setting it to 0 here. Then the index and we're setting it to J here. And then the index is 2 here. So we are setting the 2 to the J value here. So this is how we will be iterating our array in a diagonal fashion. So what we need to do here is we need to create two variables. I will always start from 0 and J will start from the index position. And what we need to do, we can have a while loop here to check if I's value is less than the length and J's value is less than the length. All right, so we have an iteration now. So once we go into an iteration, we can start checking values, right? So if I is equal to j, so what does it mean? So if I is equal to j, this basically means that oops, so this basically means that we are iterating this initial diagonal thing. So all the elements will be equal to each other. So what we can do is that we can directly set the values for I and j equal to 1. So that's a pretty straightforward condition. Yeah, and then you know what? Let's put in curly bracket and add an else block here because I don't want to go to the rest of the stuff and return and do some sort of stuff here. I just want to keep it fairly straightforward. And or else we are going to check if the difference between j minus j minus I equal to 1. So what does this mean? So this means that we are in the second iteration, meaning that we are here. So when we compare two elements, right? So we are in that state. So in this case, we don't have to do a lot. We can just directly check if the difference is 1. Why is the difference 1, right? So because we have 0 and 1 here, and then during the second iteration we have 1 and 2, and then 2 minus 1 is 1, and then we have 3 and 2 here, and then 3 minus 2 is 1. So that's how we know we are in the second iteration. And if at all we are in that stage, what we need to do is we need to check if the character at index I is equal to the character at index j. So if they are equal, we can set dp of I and j equal to 1. So that's the idea there. And only other condition that we need to check is um, the third condition where we are in a position where it's not either of these two, right? So we've come to this part now. So in this case, we need to check the we need to use dynamic programming to check all these previous values to get a value from that. So the first step that we did in that case is we are checking if the character at array I is equal to the character at array j, right? So that's the first condition that we're checking. And if they are equal, other step that we need to do is we need to also check if the dp at index I minus I plus 1 and j minus 1 is greater than 0. So that's the condition there. And if this condition is satisfied, what we need to do is we need to set the value of the array to be the value of dp of I plus 1 j minus 1 plus 2. So that's the idea there. So we are setting the value we're doing with an adding up. If we found a palindrome, we found that the elements that are between those indexes is a palindrome. If they are a palindrome, it will be greater than 0. If it's greater than 0, we can just directly add plus 2 to the dynamic programming array. And then once we do an iteration, we will have to do another check at the bottom here. We will need to check if the maximum so far is less than the dp at index that we just found. So if it is less than the dp of index that we found, we need to set maximum so far to dp of I and j. Oops. And then we need to set max start just so we have the indexes, right, where it starts and where it ends. Maximum end equal to j. So that's kind of it. Once we do that, we can increment the value of I and increment the value of j so that we can pass on to the next elements. So once we go through all this stuff, we can just return a substring of indexes I. No, it's not I. It's max start and max end. I think we will have to subtract it with one because um, anyway. So this is it, guys. So let's compile and see if it runs. I'm hoping there should be at least a few errors. So yep. So oh, my bad. I didn't realize I was using char all this while. Supposed to be using array there. So weird, guys. Sorry. Oops, I just realized we had I here because it's taking too long. I was wondering why was it taking too long? Did I have like an infinite loop somewhere? Okay, so we do get an error. We're not getting the right value here weirdly, so I'm gonna debug and see what we did wrong. So guys, I just realized that we have made a couple of mistakes. So it's supposed to be two here because we are adding, we just found out there's two characters that are a palindrome, right? So it's supposed to be two here. And here it's supposed to be plus one because we need to return the next index as well because we are using indexes so far. So it's start from zero, but like substring uses the actual locations. So that is what I found so far. If there are no errors, we should, yeah, we are getting the right value. So I'm gonna run all the test cases, see if it passes. So there it is, guys. After 9 attempts, I was able to crack the problem, but that's the basic idea of solving this. It should be fairly straightforward once we get to understand like how do we use dynamic programming to solve this. So see you again tomorrow, hopefully, with another problem. So just to give you an idea of what I'm going through, I have this really cool interview preparation, must do coding questions. So for the past few months, I've been going through it pretty slowly. Uh, so far, we've looked at all the array problems, and currently I'm on the string problems. These are kind of the must-do coding interview questions that are pretty standard in every interview. And next, once we finish off string, we're going to LinkedIn, linked list, trees, and heaps, and we're going to go through all that, right? So just to give you an idea of where we're going, things like that. So see you again tomorrow.